Okay, a little short video on Lewis structures to kind of reinforce. So from the book, in most sites you find, they'll have this formal way where you have to count the valence electrons, and then you remove the electrons and slowly add them back, and you get these kind of decision things. So I use this more informal way where I start with the Lewis dot structures that you had to learn. And so the advantage is you don't have to count. And with the old way, you had to do a bunch of structures and then use formal charges and things like that to help you decide which way is the correct one. So just a little reminder about the informal way. This is a site from Purdue Gen Chem and very nicely done. Just talking about, again, it's the valence electrons we look at, and we uh, can do this kind of informal way for doing it. And that's what I show for it. And so the kind of normal way is to then you count up how many valence electrons you have, and then you have to do the first structure, and then you have to do some math, seeing how many bonding, anti-bonding. All right, feel free to use that, but the informal way is much better in my mind. So if we start with something like CF4, so we have the carbon, it has four unpaired electrons from the Lewis structure, and we know we're going to put four fluorines around, so it's just kind of intuitive then to rewrite it. In the normal way you learn it, you have one unpaired, and you just would rewrite it then just to make everything line up. In reality, I would just have the one carbon and then slowly build the fluorines around it, getting all those unpaired electrons to line up. Once I do that, now I can just draw the bond connecting them, and then you can see the overall structure of it. You get something like this. So we have everything is in the octet rule. We can see that. And paired, all electrons are paired up, and how many lone pairs are left behind. If we look at something like BH3, again, the same kind of idea that hydrogen only has one paired electron, boron has three. So that's why we put that in the middle. Again, the alignment doesn't really work. So we need to shuttle things around. And you can see how you would start with just a boron and then add the hydrogens. We get to something like this. And again, we can pair up all the electrons and see it. The last example I have here is for CO2, and you put the structure there, the carbon in the middle because oxygen is the most electronegative, and also most of the time it goes for this high symmetry. So we put the carbon in the middle, put the two oxygens, and again we bind it up though. We put the first bond here, then we have an unpaired electron left behind over there. We can simply rearrange them, move them to the inside, so now we can form the second bond, pairing everything up. So we don't have any unpaired electrons. And now we can get this answer. All right, so we see how many lone pairs are there, and more importantly, no formal charges developed. In the second one, I'll show you about dealing with formal charges and resonance.